Hi, this is Mr. Barron. I'm going to be showing you how to do problem number 63 from chapter 16, which deals with pKa. Alright, so in this question they tell you that you have a pKa of 2.32 at 25 degrees Celsius. Then they tell you you have this compound called saccharin, which is HNC7H4SO3, and it is dissociating into obviously hydrogen ions and its equivalent acid, or base I should say. Hang on. And C7H4SO3. There we go. Sorry. There's a lot to write out. This is my HA, there's my H, there's my A minus. I'm going to use an ice table in this problem because they tell me that I begin with 0.10 molar of my saccharin. And what's happening is it's a weak acid, so it's dissociating. And initially I begin with 0 amounts of each of those. Alright, now what I'm going to do is I'm going to calculate the change. And the change, this is going to go down by some value x. This is going to go up by some value x when it starts dissociating, same with this. Notice I don't have any numbers here, or there. The reason behind that is because it's a 1:1:1 ratio for all of my stoichiometry. Now, I'm going to write out what it would be at equilibrium, 0.10 minus x. This would be x, and this would be x. And I know that my Ka is my products over my reactants. And I don't have to put them to any coefficient. There's not going to be any exponents because there's no coefficients at all. My Ka is essentially going to be this times this, so x times x, which is x squared, over 0.10 minus x. And of course that's in molarity too. Alright, now, conveniently, I know pKa. I can solve for Ka if I know my pKa. See, the definition of pKa, P, just like all the pHs and the pOHs, P just means negative log. So in this case, it's not the negative log of hydrogen ions like it is for pH, or the negative log of hydroxide ions like it is for pOH. It's negative log for Ka. So what I'm going to do is I'm going to plug in this value, which is 2.32. I'm going to multiply both sides by -1 so that I have, right here, just log of Ka equal to -2.32. The next step is to solve for Ka, and when I do that, I take the negative, or the anti-log of both sides, which is 10 to the x, and that would be 4.8 times 10 to the -3rd equals Ka. So now I have a value that I can plug in here, and I can solve for x, which will tell me my hydrogen ion concentration, which will eventually tell me what the pH of my solution actually is. So I'm going to plug in my number here, this number into here, so it's 4.8 times 10 to the -3rd equals x squared over 0.10 minus x. Now in this problem, if I want to actually solve for x in this, I would have to use a quadratic equation. But we can also make an assumption that x is going to be so small because we're dealing with a weak acid that you can make x essentially 0 for down here on the bottom and then solve for x squared. Now I'm going to show how to do it via the quadratic equation, and by the way, I want you to write out what page they show you how to do this in the book, which is page 693. So what I'm about to show, you have notes on page 693. It's in sample exercise 16.13. Okay, so I'm going to actually do the quadratic. So I'm going to multiply both sides by 0.10 minus x. When I do it to that side, it goes away. So then I end up with 4.8 times 10 to the -3rd times 0.10 minus x equals x squared. Then I'm going to take this in, multiply it by both of these terms. So it's 4.8 to the -3rd times 10 to the -3rd times 0.1, which gives me 4.8 times 10 to the -4th minus 4.8 times 10 to the -3rd x equals x squared. Then I'm going to get everything on the same side so that I have 0 equal to x squared, because I'm going to add this to the other side and subtract this to the other side, plus 4.8 times 10 to the -3rd minus 4.8 times 10 to the -4th. Now, what I have on my calculator is I have a program to do quadratic equations. I can transfer it to your calculator so that on the AP test you can actually use it. So I'm going to hit enter. I'm going to run my program. I'm going to plug in A, which is 1. Alright, so through the magic of me speeding up this recording, I have done my quadratic equation, and I have found x to be equal to 0.0196. Okay, that's the molarity for x. Now, since I know my molarity for x, I can plug that in here, and that's my hydrogen ion concentration, and I can use that to figure out pH. So don't forget, pH is the negative log of my hydrogen ion concentration. No. So this is your molarity for x, and then you take this number and you put it in for the hydrogen ion concentration. So the pH is equal to the negative log of 0.0196. And then when you do that, you find your pH, and your pH ends up being 1.71. I'll write that over here. pH equals 1.71. Quite a long problem, a lot of steps. What's important is to understand the concepts behind why we did all the steps. If you have any additional questions, let me know.